In this video, we'll look at some application concepts for spectrum measurement engines. Let's start by opening Measurement Config and creating a new tab. We'll call it RTA Stack. Next, we'll create 4 spectrum measurement engines that all use the same input signal. I'm choosing my computer's built-in microphone. For all 4 spectrum engines, we'll override the global averaging and give each one a unique averaging setting. Now we'll go to the new tab and run all the measurements. Let's separate all these traces by 15 dB of Y offset so we can see them all. Since all 4 measurement engines are using the same input signal, we can easily see the effect that the averaging settings have on the data. Notice in the upper right corner of the plot, the dB offset is shown under the plot name. We can clear them all by using the reset Y plus minus or the hotkey Control or Command Y. Now let's create another new tab called RTA Live Average. We'll create spectrum measurement engines for the built-in mic and for the measurement mic. Now I'll create a live spectrum average and set it to create a dB average of the 2 mic inputs. I'll also create another live spectrum average and set this one to power average. Now let's go to our new tab. And I'm going to change the RTA display settings to lines just to make this demonstration a little easier to see. Now we have a real-time average of the spectrum measurement engines. The dB average is a simple mathematical average of the data. The power average is more like an RMS average. It gives more weight to higher magnitude data. If I hide one of the contributors to the average, it's still contributing to the average, even though we can't see it. However, if I pause one of the contributors, it stops contributing to the measurement. Now the average becomes the same as its single contributor. If I add a single dB offset, it's easy to see. Don't forget to change your RTA setting back to bars so you don't confuse it with transfer function data later.